In this session, we are covering leveraging connected camera traps for wildlife conservation and protection. So that's what the session is about. All right. So my name is Kusasa. I'm part of the EarthRanger support team. And I just have to say that it's quite great to get to meet a whole lot of you finally face to face instead of talking to the screens. And one of those people are the guys from WPS, Wildlife Protection Services, and Wildlife Protection Solutions, sorry, WPS, who are here to give this presentation. So it will be Eric Schmidt and Matt Hron.
Awesome. Thank you, Kusasa, and I would echo the sentiment. It's wonderful to meet you and all of you who have joined us this afternoon. Really appreciate the opportunity. I'm excited to talk to you today about camera traps and their practical application for a variety of conservation issues, from ecological monitoring to protection. But before we do that, I'd like to take a bit of a step back and introduce my organization, Wildlife Protection Solutions. We were founded 10 years ago now. And in that time, we've grown to an organization of about 20 individuals, with people on staff ranging from technologists, software developers, field wardens, people who implement camera traps globally in service of field conservation organizations who are doing the important work of keeping animals alive on the front lines of conservation here. Fundamentally, when we began WPS, we knew we wanted to make a global impact, and we wanted to do that primarily in the most concrete way possible, which for us meant spending a lot of time looking at how we can implement real-time technology and surveillance solutions in service of organizations who are working on the front lines. That means we've had a lot of opportunity to refine these techniques that I'm going to be talking about briefly, and figuring out how to practically apply and operationalize this technology. In those 10 years, we've really developed a refined process that begins with an understanding of what a given protected area is up against with regard to the conservation challenges it faces. So we oftentimes do some sort of a site assessment. Sometimes that's remote, sometimes that is in person. But after that, we spend a lot of time thinking about what are the appropriate power solutions that we need to apply to a given conservation issue. Is it solar, is it wind, is it mains, what have you, and we'll spend time mixing and matching to come up with the correct answer there. From there, we can begin looking at different types of digital relay technology, radio waves, private networks, things of that nature, and we have expertise in deploying those. And that finally allows us to take the next step and decide what kind of remote sensor is most appropriate to help this conservation area with the challenges that they're facing. And then the final step in this process here is looking at what type of computer or machine learning or AI systems can we apply to this data to help decision makers realize what actions they may need to take. And we'll talk about that a little bit more in a moment. And finally, we don't neglect the human element in this. It's always our intention to be building strong partnerships with the conservation groups that we're working with. And so we spend a lot of time and energy focusing on on-the-ground training and continued support of these efforts as we progress and proceed with conservation. So establishing long-term relationships is key to what we do. Fundamentally, what this looks like for us in the camera trap and remote surveillance world is beginning with a variety of different types of cameras. So we realized early on that it's very important because a lot of groups get technology donated to them. Sometimes different vendors are involved in the mix. You want something that can bring all of that together and make sense of it in a cohesive manner for an ops room or a ranger or someone who's responding to a wildlife necessity right away. So we have approached this by sort of adopting as wide a variety of technologies as we can to support as many different camera trap and sensor types as possible. Once we understand what the cameras are that we're working with, the next question becomes, how do we activate them so that they can communicate in real time. Traditionally, we'll use things like 3G or 4G cellular networks, but in places that those don't exist, we have opportunities to do things like long-range private radio networks. Some of you may have heard of things like Buckeye cameras, or there are other types of networks operating in the 433 megahertz ranges that can be leveraged for this, or even long-range point-to-point or point-to-multipoint Wi-Fi. But whatever network we choose, the important thing is that the data begins flowing. And from there, we can then have that flow into a variety of different machine learning or AI analytic platforms through the tool that we have developed called wpsWatch. What we use these AI platforms for is the identification of a variety of different things. Sometimes that's vehicles where they may not belong. Sometimes that is people in protected areas where they do not belong. Sometimes that's ecological monitoring for animals or different types of species to understand movement patterns or just where things are happening. And we'll talk more about that later. But once the AI has gone through and looked at this information, we can take the next step in the data chain and send out alerts based off whatever the AI finds. So that can be a global affair. Most oftentimes, that information is pushed through to the first responders in the field, the rangers or the people who are responding to a given poaching or other ecological incident. Sometimes it's people in an operations center. And sometimes, if a group wishes to cooperate with us in this way, we can also take advantage of time shifting. Since we are based in Denver, Colorado, and not all groups have a 24-hour operations center, we can do monitoring in the daytime when it's other people's nighttime, and also help as an extra layer of eyes if groups want us to participate in that manner. But the important thing is we try and meet you where you are, and oftentimes that means getting the data direct to a mobile device or other third-party platforms such as EarthRanger, ThruGundi, or Smart. A few examples that I like to talk about with regard to the practical application of camera traps are really valuable. One that has been surprising to us is early detection of fire. This wasn't something that we had initially forecasted when we began WPS, but there have been several instances where we've been able to see smoke on the horizon, or indeed flames, as in this example, and that was the first indication that a protected area had an issue with a fire. So kind of neat to see eyes on the ground being an early warning system for that. Secondarily, we've seen a variety of different protected areas looking to protect their infrastructure. Oftentimes thieves are coming in to steal solar panels, batteries, cabling, well pumps, a variety of different things. And so you can, because these cameras are so mobile, wire them up almost anywhere and hopefully prevent loss of infrastructure over time, an unexpected benefit for an otherwise wildlife protection platform. But this also can expand to the concept of extractive uses. For example, this comes from a cave in Jamaica, where this fellow is actually pulling guano out of a bat cave that is otherwise protected. And this is important because he may be bringing different types of disease or other zoonotics in there and threatening the species of bat, which is resident there. So protected area managers need to prevent, or at least be aware of, and take steps to prevent that over time. And because these cameras are in real time, they can go ahead and issue ranger dispatches to intercept this fellow and tell him not to do that sort of thing going forward. Likewise, cameras have been used extensively for ecological monitoring for years and years and years, but they haven't always been connected. With the advent of connected cameras and their practical application with AI, we're seeing some new kind of ways to do ecological surveys. This project in Brazil is using cameras deployed high in the rainforest canopy to identify when iterant primates are moving through the area. This immediately alerts the teams, who may be anywhere from a few kilometers to several hundred away, to come out and while the monkeys are in the area, be able to put up thermal drones and conduct a proper aerial count and survey to get a better handle on this Mariqui population, for example. The flip side of that in ecological surveys is the elimination of invasive species. Many times on island locations, you have native birds or other flora or fauna that are being threatened by things like rats or cats or goats, and conservation efforts involved are removing those to every extent possible. And so you will see groups such as Island Conservation mount incredible efforts to clear off all of those invasive species. And it's important that they get every last one, because if you leave just 2, we all know that 2 become 4 and 8 and. And it's estimated that with real-time cameras indicating when a project is seeing a invasive species, especially toward the end of an eradication effort, they can shorten the time that it takes to put a bow around and complete that entire effort by as much as 30%, which can result in cost savings of many, many thousands of conservation dollars. Finally, the idea of protection of animals directly is something that real-time cameras can help with. This was an example of a leopard that was caught on one of the real-time cameras that people had identified because it had a severe injury to its neck. Now, the veterinarians knew this animal was in a particular area, so they went ahead and deployed a baited cage to try and capture it so they could treat it. They deployed a camera so that they could tell when the animal was captured in the cage without having to constantly check on or disturb it or otherwise frighten the animal away. So here in the upper part of the screen, you see the leopard actually in the cage. In the lower right part of the screen, you actually see the veterinarian pulling up to begin treatment. And I apologize for the grisly nature of this, but they discovered this animal had been snared around the neck. They were successfully able to remove that, and the animal went on to have a complete life. And then finally, there's what we would all traditionally think of as the security model for real-time cameras. So this example is a good one because although this particular location was not one that was regularly patrolled because of its remote nature, the real-time cameras revealed that this fellow would come into the park every day at about 6 a.m. So day 1, he was there. Day 2, that he was there with a friend. By day 3, the warden was able to use the real-time nature of these to establish a pattern of life, as they refer to it, and be able to use this knowledge to go ahead and deploy field teams for a lie-in-wait situation. They repositioned the cameras, and on day 4, when the poachers came in, they were actually able to pursue the individuals. The pursuit was actually caught on camera, and they were able to make appropriate arrests. So a good example of the real-time cameras compressing the time it takes to uncover that pattern of life and build an appropriate conservation response for that. And then finally, there's what I think of as the most real-time nature of cameras, which is direct intervention to an active incident. In one particular location, this park or protected area had several high-value species, including rhinos. They had asked us to perform a complete assessment, and in that we had identified several different locations that could be potential choke points or points of likely travel for intruders. We went ahead and wired those up with a variety of different types of cameras, and within 2 weeks, about 2 in the morning, we saw 2 spotters followed by a poacher with a high-powered rifle. Now, in this particular protected area, they did not have the benefit of a 24-hour operations room, so this information was actually first intercepted by our team in the Denver area in Colorado. Following the standard operating procedures that we had agreed upon, we went ahead and got in touch with the warden. They were able to activate the rhino protection units by calling and WhatsApping and immediately getting in touch. And within 15 minutes, we saw the response team on the same path of the poachers. This actually resulted in a firefight between the rhino protection units and the poachers, prompting the poachers to actually drop all weapons, flee the area, and we were able to see the post-crime scene analysis happening on the cameras as well. So an interesting conservation story where someone around the world actually had a direct hand in helping to prevent wildlife crime before animals could be killed. But cameras can potentially do more than that even. We are actively working on technology now to help deter human-wildlife conflict. The concept of operations is similar, but with a few bolt-on additives. For example, we would still be using the same types of cameras that we have used for poaching and ecological monitoring for years now, but putting them in places that we know are sensitive to human-wildlife conflict or animal intrusion especially. The same engine ingests the imagery and is looking for animals in the same way that it does currently. And instead of merely alerting various wardens or EarthRanger or other stakeholders, we actually have now developed technology that can be activated in the remote field sites to trigger any type of electronic device, whether that is playing loud sounds, flashing strange lights, klaxons, scent dispensers, things of that nature. But concurrently, that can be pushed to EarthRanger for direct community alerts, and even be able to trigger these devices through a call tree, or even have them prompt to local movement with simple motion sensors and things of that nature. So we view camera trapping and real-time nature of that as an ever-expanding possibility for wildlife protection. A couple of things that I would like to draw out as key factors for success before I turn it over to my colleague here, Matt, for a demonstration of how this works, is success really begins by carefully thinking of where you want to put the equipment that you want to use to surveil. So if you have known poacher routes or places of likely intrusion, start there. Paying close attention to the battery levels is incredibly important for success for these devices. Using solar wherever possible is absolutely key because they are so power hungry. And if they lose too much power, they simply do not relay the data that you need. Putting data subscriptions on automatically renewal plans is absolutely essential, because the last thing you want to do is get through part of a month and have your camera no longer be able to transmit information that you need about your protected area. Being clear about who is monitoring and when they're monitoring so that you have as much coverage as possible, and what to do if someone does see something. Fully develop standard operating procedures for having those, for when those incidents do arrive. And then always monitor and maintain the network. And a big part of that is having sufficient spare components so that if something does go wrong, a baboon chews a wire, a monkey pulls something out of a tree, a termite builds a mound in the camera, you have something that you can do to replace that. And then finally, and this is, I believe, is perhaps one of the most important ones, take advantage of data interchange by pushing this information up to other systems such as EarthRanger or SMART, and be able to do analysis with that and further inform your strategy of how you're gathering this surveillance and how you want to respond to the incidents that you are collecting. So having said that, I'd like to bring Matt up now and invite him to do a quick demo of the tool that we use to do the artificial intelligence analysis and alerting.
Well, hi everyone. I'm Matt Rohn from Wildlife Protection Solutions. I work closely with our software development team as the product manager for wpsWatch, as well as with our global conservation partners and implementation and support of this product. I'm going to start by attempting to do a live demo of wpsWatch. The Wi-Fi has been a bit finicky, so let's hope it all goes well, but I'll give it a shot. So what I have here is just an example of the type of camera we might use. As Eric mentioned, we strive to be able to work with any type of camera that can send the images in real time. And let's get a nice shot of the audience here. So if we have connectivity, should be able to send in this photo to wpsWatch. appears that I don't yet since I just turned it on. So what I'll be doing today is showing you wpsWatch. For those of you that have used it already, you might notice this looks a bit different. So I'll actually be introducing a new version of our website that we started rolling out recently, and for anyone using it, we'll be contacting you in the coming months to get you started with the new website. And it looks like I'm not able to get a Wi-Fi signal here, so we will... That's actually from right before we started this session, so I prepped my screens just in case the Wi-Fi wasn't cooperating, which turns out to be a good idea. So what you're seeing here is our new wpsWatch platform. I'm going to give you an overview of some of the new features and highlights. We will have time at the end for any questions anyone has, and for more in-depth overview if anyone wants to grab us while we're around. Happy to show you more. So what we're looking at here is a brand new feature of wpsWatch, a dashboard page. This is intended for real-time monitoring, perhaps in an operations room. You can configure different dashboards to view the photos you're interested in and have a feed that will update in real time. So as photos come in from the field, you'll see them pop up right away on the screen, which would have happened if I would have been able to send a photo. But you can see here I've created different types of dashboards for different views. So I could have a view that contains all of the photos coming in. If you really want to make sure you don't miss anything, you want to review every single photo that comes in, you can have a feed that will show you all of that information. If instead you're interested in more targeted applications, in this case I created a threat monitoring dashboard. Anytime a person or a vehicle is detected by the AI, that will automatically feed into my dashboard. In this case, I don't need to worry about all those images of maybe branches blowing in the wind. This will just be the things that I'm interested in terms of threat monitoring. And you can even see with this photo of small people in this big room here, AI was able to pick out those individual people in the software. Also have a view here for wildlife monitoring. So this is something if you are an ecologist and want to see the animals that are detected in real time. Also cool application would be having this up as a dashboard in a lodge or somewhere where you have guests so they can see what's happening in your protected area, the cool wildlife sightings of the day. So as you can see, generally, for those that are familiar with wpsWatch, it has a new look and feel and navigation, more modern, responsive user interface. So I can scroll and have the menu hidden when I don't need it, but quickly access it when I do. One cool thing we added for the dashboards is a full screen mode, make better use of that space. So now we can see more on the screen at once, and this will update in real time as images come in. We also added a dark mode. So for those looking at wpsWatch at night, very, very helpful, easier on the eyes, and also if you're in the field, last thing you want is a bright white light shining from your phone as you're trying to respond to security events. For the photo review tool, which was, we'll just go to new tab, photo review tool, which we've had in the past, we've added a lot more flexibility in how you're able to look for the photos of interest. So you're now able to search for photos by individual cameras, linked incidents, any tags in the system. So that's whether we determined it's an animal or a person or a vehicle or individual species, as you might be doing that, as well as looking by date range. So you can go back and look at historical information a lot easier with these new search tools. This is just an example of what it looks like when you click on a photo. And here you can see AI is detecting what's in these photos. And as Eric mentioned, based on what's detected, we can automatically send alerts via WhatsApp, SMS, or email to anyone that needs to be informed, as well as send to systems like EarthRanger if people are primarily monitoring for real-time information there. One of the important things for this update was really making the website really mobile friendly. While it's great to have the dashboards and the website tools for reviewing photos, most of our users are actually in the field just receiving the alerts on their phones and responding to the information there. So very important that they can access the information they need very clearly and be able to access everything. So if I represent more of a mobile view here, you can see that it's a lot easier to view the information. It's presented in a very nice, simple way. We added a couple other features for more accessibility for other people. One being able to specify your coordinate reference system. Previously, we had assumed everything was decimal degrees, but recognize that a lot of people use different reference systems, so being able to see those in a way that's meaningful to you will be helpful. We also added language translation support. So right now we just have French as an alternative as a proof of concept, but the structure is there so we can very easily add any other language that users want. Looking forward to that opening up wpsWatch to a lot of people that maybe aren't native English speakers. And last, I'll just show here, this is an example. Oh, and we have a new update here. So I just set up the alerts to go to my email, and here you can see is the message I would receive in real time as this photo came through. And also we do have the ability to send images to EarthRanger flexibly. So if you want all your images of people or animals or whatever to come into EarthRanger, we can send those in as reports. So if we look here, they will come in as camera trap reports located on the map in the location of the camera you have specified in wpsWatch. And if I open up this report, I can see which camera it came from, as well as view the image directly. So if you're using EarthRanger and maybe not logging into wpsWatch all the time, you can still access that information in real time. So I'm very excited about this updated software platform. And as I mentioned, we're going to be continuing to roll it out over the coming months. And I think that's all I have. Do you want to open up to questions?
Outstanding. Yep. What questions can we answer for you all? Yep.
Yeah, thank you, Matt. I was looking at your presentation, and then I discovered that the AI were like giving a positive identification of the wildlife species, right? Is that accurate, or did you train the AI to do that? And if you did the training, for how long did it go the concept of positive identification?
So some of the AI that we're using is commonly used in the conservation community. So you may be familiar with Mega Detector. That is what we use as our primary threat detection. It will classify people, vehicles, or animals. For the species-specific classifiers, that's something that we are now developing ourselves. So that's something where we've created those models, and a really great part about it is we now have the ability to refine them over time. So maybe at first you will miss a few things, but as we get more and more data, we can retrain the model and make it work better for your context.
Yeah, how long have you been training the model?
The species one you saw here, we actually put together in about 3 weeks.
Okay, thank you.
The other thing I'd like to add as color commentary to what Matt said is we've designed wpsWatch to be an extensible platform so that we can over time incorporate new AIs that can support a variety of different models. So while we have some that are in there currently, we're certainly open to a variety of different AIs because we ourselves are not developing the AI technology. We're simply finding third parties that we can cooperate with, building that ability to link up to them into the platform to allow you all maximum flexibility to say, hey, I've found this AI that meets my needs perfectly. Will you, WPS, integrate that into this tool? And the answer will be yes.
Yes.
I wanted to find out if there's a limit to the number of characters or animals it can detect in a single frame or picture.
Not that we've encountered. So sometimes we have images from a watering hole where there'll be 50 plus impala and zebra and other species, and it will detect all that it finds.
So it's something that you could use, say, to speed up game counts when you've taken all your pictures and just feed it through the wpsWatch.
Yeah, it could be potentially used for game count information. We currently don't have a great way to automate that quantifying the number of them, but that's something we could help you with on the back end doing that reporting with you.
Thank you.
Hi, yeah, I wanted to ask, so about the transmission of the data, is it all stored somewhere or just the one that's picked up by the AI in terms of people or wildlife or whatever is of interest to the people watching and setting up the cameras? I mean, it's probably of high interest, not just for security, also for research, because, with normal camera traps, you'll have the problem of a full SD card or batteries that run out after a couple of weeks, or someone stealing the camera and you losing the data in it. So it'll be great if the entire amount of data could be stored somewhere, with any species or any activities going on, sort of saved somewhere that can be accessed. Is that the case?
Yes, because most of the cameras will transmit all of the images that they take, wpsWatch does ingest all of those and it stores all those. So you have a complete record of everything that the camera has done. We do work with some cameras that use edge detection, artificial intelligence, and they can be set to only transmit images that they think are relevant. And obviously that's, would be an exception to that rule. But for the most part, anything that's sent to wpsWatch is stored there for future accessibility.
I wanted to ask about linking these cameras to EarthRanger. We tried to do that, and we experienced some challenges with which I find it good to find out from you. Within time, the camera were not showing signals on the ER. So what are some of the reasons as why that happened, and how can we overcome that?
You want to take that one?
Yeah, I guess first of all, happy to help you directly with that. If you want to sit down, we can take a look. If the photos are coming into wpsWatch but not EarthRanger, there are a few different reasons that could be. One is within wpsWatch we have flexible configuration, which is where you make that decision where you want photos sent based what's in them. So if that isn't configured to send certain photos to EarthRanger, then those wouldn't be getting through. We have seen other issues where maybe the user associated with that integration in EarthRanger has a token that has expired. In that case, it would no longer be able to communicate. So there are a few different things, also permissions issues within EarthRanger, but I'd be happy to take a look at that with you.
And finally, the other potential there is simply that the cameras may have just gone offline out in the field, and typically that happens for one of two reasons. Either the battery has run flat, that's why we always recommend using solar, or the data plan has expired, which is why we recommend always having that monthly plan or regular top-up maintenance that you're monitoring actively. But as Matt said, stop by the booth over there and we'd be happy to take a closer look and get it resolved.
On that note, I'll mention that we do have the ability to send the photos directly to EarthRanger, but we also have the ability to send the photos to Gundi, which you heard about this morning, the integration platform. So this would give us the ability to send those photos to other endpoints that are connected as well.
Cool. Hi. I just wanted to check is there a distance limit to the AI?
The distance limit would typically apply to the sensor of the camera. The AI itself, generally we try to train it using a variety of photos that represent different distances, light and dark. There are limitations. If something is very tiny, more likely that it will be missed. AI in general is imperfect, but generally for the as you can see in the images that are coming in live now, the person detection is able to pick up very small objects.
Hi, Matt. So I wanted to know, so we want basically, for instance, like all of our lions in one place, our lion data. So currently, as you know, on Aljogi, we've got, for security reasons, the human detection that gets sent through to EarthRanger. Would it be possible to then also send through like a giraffe or lions as that species template, or is it only able to come through as the camera trap?
Right now, the integration only supports that specific camera trap report type. One thing we are talking with the EarthRanger team about and hoping to do soon is be able to send that tag information over to EarthRanger. So within that report, you would see what was detected and be able to search that within EarthRanger as well as in Tableau. Any other questions?
Yes. Thank you for your presentation and for sharing the progress so far. I think I'm delighted because from the first times when hyenas would move the cameras in the field and we would not know what happened to the time when the poachers would take them off, today at least we can share. And I'm happy in Mount Elgon we're now able to see, actually see that the elephants are getting into the caves. So my then desire is to get the cameras into the areas where we cannot as human beings reach. Is there something that we are working on, or is it something you can help us achieve at a time like this? Thank you.
Yes, I'm curious, when you say humans can't reach, does that mean physical access is difficult, but you can make it in like 1 or 2 times, or is it completely impassable because of flooding or something for some reason?
No human access.
None at all whatsoever, forever and ever?
Like into the cave, and you can't get deeper than...
Into the cave you can't go?
I'm talking about access, let's say, into the cave, beyond what a human being can do.
Yeah.
Is there a way we can get AI camera trap into those areas that are inaccessible?
I mean, you would need to think cleverly about how you could physically get some device in there. You know, right now the limitations of the physicalities of it is that a human has to take some sensor, whether it's a camera or a microphone or something, to be able to go over and, you know, position that device so it can detect whatever you want. There may be clever ways. A lot of people are exploring things like drones or other types of devices to be able to do long-range remote sensing. But that, I believe, is still on the horizon, if I'm understanding your question correctly. Other questions we can answer for everyone? All right. Thank you very much. We appreciate it.